Dark Souls 2 for the Nintendo Switch. Today we're going to be kind of mimicking this targeting system, or I guess I should say you're going to be watching me recreate this targeting system in Unity, sort of step by step, but I wouldn't recommend the entire video as like a tutorial. But there's a lot of important stuff in the clip, so use the footage however you want. But other than that, moving on to the video. Whoa! Okay, so the first thing I do here is mark my main camera as player camera using the tag system in Unity. This is just an easy way I found so that I could kind of access the camera via code in a really easy and simple way by calling GameObject.findObject with tag, something along those lines. But that's not really all of it either. Once you do find object of what is it? Find GameObject.find object with tag. After you do that, you need to get the component, the Cinemachine freeload component from that object, because what we need is that camera component, the actual thing that we're going to be manipulating, right? The camera, not our main camera, but the Cinemachine camera. There's a difference. And if you don't know, you might have to look up Cinemachine on your free time. I'm going to be honest, this next part's a little hard to explain, but I'm going to try my best. So, what I'm doing is I'm running around the ball, and I'm trying to kind of mimic the targeting system using like manually, right, with the right stick. And so I'm just making sure that as I'm running around, I am moving the camera in such a way that it's almost like I'm pretending that the camera is targeting that ball. And I'm also keeping a track of the x-axis value, because that's kind of the core of what this is. You're just going to be looking at the player's position relative to the ball, and wherever I am next to that ball, the camera needs to rotate in the x-axis value so that it's facing the ball. And that's kind of it. Now let's get into the nitty and gritty of how it's actually done. And so this is going to take a little bit of prior information about vectors and directionality and what else? Angles, I think. But what I'm basically doing here is I'm creating a directional vector which points from the ball to the player, and then I'm cross-checking that angle with just the world's forward vector. So, man, if you can kind of imagine it, I don't know, picture like two arrows like on a clock. And then you can check the angle between, like, let's say it's, I don't know, 12:30. What does 12:30 look like on an analog clock again? The big hand on the 12. No, the small hand on the 12, little hand on the 30. And you kind of just say, okay, well, what's the angle between the two hands? Okay, that's the core of what we're doing to get the angle from the ball to the player. And when we have that angle, then you can say, okay, camera, rotate, boy, you need to be looking at the target. And now whenever we target, we just plug that value directly into our camera, or our camera's x-axis value, and that's kind of it. That's really the basis for at least the x angle part. The y angle, like having it go up and down, was like a bizarrely huge challenge. It's actually the last thing I tackled because I just could not figure it out. So, in the name of trying not to procrastinate, the next thing I tackled was switching targets and like sorting all the targets that are in the target pool. So, unfortunately, that's one part that I didn't actually film, was how to pool the targets. You know, how to say, okay, if the target's on screen, it's a target. How do we define what a target is? You actually can't see it. There is a bit of like, it's right on top of the code from the last section we were looking at. You can kind of see how I did pull out those targets. But the cool thing about lists in Unity is that it does come with its own sort function. How cool! But well, the cooler part along with that is that you can create your own sort of comparer class, which I just call distance class because it is kind of sorted by distance. But within that within that comparer class, you can have a function there that is called compare. It returns an integer, and then if you want it to be on the left, or rather, if you want it to come first, you just, it's weird. You can calculate it yourself. You manually calculate. You you manually compare two objects, and then you say, okay, if one object should be first, you return -1. If they're both equal, you return 0. And if one object should be on the right in that sort comparison, then you returns 1. And that's huge, because this sort function also can find, and I think it's based on the size of the list, but it can also find the optimal sorting algorithm. So computer science people or programming people, one of the biggest questions in like those exams is like, what sort function should you use? And min, or was it bag sort? Um, um, oh, insertion sort. That's like all I can think of, if I'm going to be honest. But either way, you can kind of define how to sort these things. So what I did was, you can compare all the positions of the balls, and you just check them with their position on the camera's viewport. So in layman's terms, if the ball is like further left on the screen, it gets put in the first place. And if the ball is on the right side, or closer to the right side of the screen, it goes into last place. And then that's literally how you sort it. It's sorted between their position relative onto the screen. And so this part that you're seeing here is, I'm just adding like input detection for when the player is flicking left or right on their control stick. We can use those inputs to then switch our target in that target pool. So that's kind of why we sorted it from left and right. It's so that when you're looking at something and the player flicks left to select the left, or to select the target that's on the left, we now have that array sorted. So we know what target is on the left, if there is any. And then if there is one, you guessed it, it gets selected. But other than that, that is the basis of target selecting logic. The only other two things I had to touch up here were, one, the camera is still reacting to your input. So since it's a free look camera, it does take its rotation logic from the joystick itself, but we have to negate that. We have to set its axis speed to 0, so that the only thing that's rotating it is our target logic. It's the only thing that takes control. That's why you see a little bit of a jumpiness to it. The second thing we have to touch up is something that you may or may not have noticed in Dark Souls 2 footage, but it's this lerp function, right? It's this smooth transition between targets, so that you can kind of tell where the camera is going. Because without it, as you saw, it was very jarring. It was very snappy, and maybe there is such thing as being too responsive. But other than that, that was all we needed. Really, it was just about touching up that lerp speed so that the smooth transition feels good. But we can move on.
Watch out!
Whoa! Ocarina of Time footage in my serial? Who put that there? Yes, the reason why we're looking at Ocarina of Time footage is because we are going to take something from a game that I liked growing up, or a game I liked in the past. And the only real difference the only thing I'm really taking from this Ocarina of Time thing is that arrows, those 4 arrows. It's just so nostalgic, and it feels great, and I don't know, I never really vibed with the Dark Souls 2 circle thing. If I'm going to be honest, and this is a hard read, but I think the people who made Dark Souls 2, they wish they could have used the 4 target system, but for whatever reason, I don't know. Maybe they thought they were too cool to use 4 arrows or something. Like, I mean, it's not. I mean, it's primitive in a sense, but why not? It's so cool. So let's do it. Let's add it ourselves. And how do we do that? Well, it's simple. You just have a parent target canvas that holds all 4 arrows underneath it. All 4 arrows, they're all basically the same. Just make sure that each arrow shares the same pivot value for the X and Y, which is 0.5, 0.5. And then also make sure that its pivots are set to the correct positions, and what is the other one? I think it's also pivot. But I hope this part's a little bit self-explanatory. Your top left arrow will be set to top left, top right arrow, top right, bottom left arrow, bottom. You know the rest from there. Also, make sure to rotate the arrows so that they're all facing inwards. Top left. You know what? I actually don't know the rotations off the top of my head, but also as I'm seeing the footage. It's called anchor presets. Pivots are one thing, but make sure the anchor presets are correct. So top left arrow should have its anchor preset be top left. Blah blah blah. Yeah, here I was just one, I was double checking the size that it should be based on the Ocarina of Time screenshot. But really the next step is also animating this thing. So I created a little folder to hold all the target stuff together. I had an animator controller that'll actually handle, what animation state to change to. And then I have 3 animations. One is just called Enter Target, which goes from being obviously really big and off screen to shrinking down to its final size so that it's visible on screen. There's an Exit Target, which is just a reverse of that, right? It goes from its on-screen size where it's visible, and then the animation increases it and maxes it up so far up that it's hidden from the screen. And then the most beautiful one, the most eye-catching one, the most nostalgic, the one you picture in the Ocarina of Time, there's the animation for when it's actually targeting. And I'll give you a second to guess what it is. It's the rotation animation. It's the one where it spins in a circle. There's actually the funniest little bit about this is that this wasn't, another thing about this that it wasn't straightforward that you'd think it was having it rotate just smoothly and like continuously. It always does animate smoothly because Unity uses its curves. But having it like continuously rotate in such a way where it's like you can't even tell that the animation ended was weird. It was visual on screen, so take a look if you need to. But all you kind of do is you just make sure to flatten the curve. Basically, just make sure that the curve is set to linear rather than have it be any other smooth algorithm. Next up on the list is now turning on that target animation. And so what I did here in this script called human, where it handles all the input from the player. Here I just sort of got a reference to that game object, our target canvas game object, the one that we created that holds all 4 arrows. And really the magic that happens here is whenever the player is targeting, no, not even that actually. Whenever the player is targeting, but also there is a target selected, then we just turn the canvas on and we let the canvas do its magic. That's the beauty about the animator controller, is that some animations don't start until that game object is active. So if we want the animation to start, essentially, if we want, what I'm really trying to say is when we want the enter target animation to start playing, all we have to do is turn on the target canvas component, or not even that, the target canvas game object, and then that will turn on the animator, and then that will play the first animation, which is the animation of the target going from really, really big and off screen to not really, really small, but small to the point where we can see it. From there, it just naturally jumps into its rotation animation, and it'll stay rotating until we lose our target. Last thing to note before we move on is that I also did take that canvas and I made its position equal to wherever the target's position is onto the screen, so that you get this really nice tracking. Like it really is locked on this time. We are locked in this time for the month of March. And what you're looking at here with this nice blue line is a visual representation of how we get the final angle so that our camera snaps to where we want it to in the up and down. And that code right there that you're looking at is like the really important one. Take a look at it, dissect it if you really need to. But once that part was done, it was just about finding some sound effects and then also creating this script here so that when you enter that target, rather when the target animation starts, it plays a sound effect, and when the target animation exits, aka the little target zooms out, another sound effect plays, and you'll hear it here in a second. But man, we did it. That's the end of this video for the most part, but let's see the final product. And that's it for this video. Check it out. I think it turned out pretty nice. Are there little flaws here and there? Maybe. But does it accomplish what we needed to accomplish? Yes, I think so. It's not quite the same, arrow size or same visual kind of character that Ocarina of Time has, but it does feel like a nice blend between Dark Souls and Ocarina of Time for the most part. Obviously, some of the movement stuff is going to have to be changed because you walk super slow when you're targeting. But other than that, I think we did it. I think we knocked it out of the park with this one.